In this lecture, we're going to see how we can combine concepts using logical operators. We can combine concepts using the AND operator and the OR operator as you see here. Let's look at a simple example. Here we have a concept. It is tiny type we have seen before, and it's going to check that the size of the template parameter we pass is less than 4. It's going to enforce the syntax with a simple requirement, but it's also going to enforce for the value of this expression to be true. If the value is not true, the concept is going to fail, and we are using a nested requirement for this. So this is our concept here. Let's try and set up a function and see how we can combine this concept with other concepts. Here we have a function. It is going to return t. The name of the function is func. It is taking in our parameter. And here we have the body of the function within these two curly braces. But what we have here is a concept we want to apply to this function here. And the first line here is going to show that we can combine concept like we do here. So this entire thing is going to be a logical combination of concepts. So we can require that the template parameter be either an integral type or a floating point type using the OR operator here. Another thing we can do is use the AND operator as you see down here in this second line, and we're going to require that the template parameter is both integral and a tiny type. And the compiler is going to enforce these things as we are about to see in a minute when we hit Visual Studio Code. You can even specify your concepts in place. For example, the third line here is going to say we require for the concept to be integral, so it should be an integral type, and we're going to specify our tiny type concept in place. You see, we are doing that right here in the function declaration. And this is going to work. This is a valid C++ syntax, but I don't recommend this because this is going to make your function declarations really ugly. So now that you know this, we're going to head over to Visual Studio Code and play with this a little more. It's just using the OR and AND operator to combine concepts. Okay, here we are in our working folder. The current project is combining concepts. We're going to grab our template files pretty quick and put them in place. And we're going to open this in Visual Studio Code as we always do by dragging and dropping here. We have our file. We're going to open that up and close the left pane here. I don't like it. And we're going to include our concepts library. Let's do that. We have this in. The first thing we're going to do is to put in our tiny type concept here. So it is tiny type. It's going to require that the syntax for size of t less than 4 be supported. This is a simple requirement again. And we're going to require that this expression be true. And we're doing this using a nested requirement. Okay, now that we have this concept, we can combine this with other concepts. Let's use the same function we've been using all along. So we're going to say template type name t, and we're going to put in our requires clause. So we're going to say requires. We can use std integral and say t and say, or it should be std floating point. I think we have this in. This is a concept we have, which is built into the C++ standard library. We can use this. Now that we have this, we can then say the signature of our function tadd. It's going to add up ta and tb, and it's going to return the sum of a and b. Now, you can only call this function with either integers or floating points. If you try to deviate from this, the concept is going to fail, and we're going to get a compiler error. Let's go down and try this out. We're going to say int x and put in a 6, for example, and int y and put in a 4. And we're going to add this up. We're going to say add x and y. And if we do this, this is going to work because this is an integer, so the concept here is going to succeed. Let's build with GCC and show you that the build is good. The build is good, so no problem. We can change this to double. It is going to work because double is a floating point. Let's say double properly. And if we build again, the build is going to go through. But if we try and use, for example, a string, let's say std string, that's a string. And we're going to change this into double quotes. We can do that and say std string and put this in quotes again, double quotes. Okay, if we do this, you see we have a squiggly line. And if we build, we're going to have violated our concept because the parameters that we pass don't satisfy this concept. It's neither an integral type or a floating point type. And if we go up here, we're going to see that we have violated a concept constraint not satisfied, and it's going to say the concept that was not satisfied here, which is right here. Okay, you can combine two concepts using the OR operator, but we can also use the AND operator. Let's go down and try and put up a simple example that is going to do that. Now, what we're going to require for people to use this function is to satisfy both tiny type and integral. So we're going to say requires std integral. I think we have this n, and we're going to say and tiny type, and we're going to say our template parameter here. The moment we do this, and let's turn this back to being int, let's say int x, and put in a 7 what we had before, and int y, and say 4 or a 5, doesn't matter. If we do this, let's see our thing again. So tiny type requires for the size to be less or equal to 4. So int is going to work. This is going to build because the concept is going to be satisfied. It is both integral and tiny type. Let's build and see this run. You see the build is good. Our concept is satisfied. But the moment we try and use something that is greater than 4, we're going to have a problem. Let's use a double, for example. We're going to change this to double and build. We expect compilation to fail because the type, which is double, doesn't satisfy the tiny type concept. And we're going to see that here. Okay, so we're going to see build finished with errors, and we're going to have a lengthy error here. But the meat of this is that we have a constraint which is not satisfied, and it is that required for the satisfaction of std integral. So double is not going to satisfy this. I think double was a really bad example because it's not integral, so integral is going to fail. What if we pass in long int, okay, which is really an integral type, but it's not going to satisfy tiny type. So let's say long int, and we're going to build. Now we are going to violate, let's use long int, because I think long int is not large enough. So we're going to build. Now we're going to fail because tiny type is not satisfied. You see, required for the satisfaction of tiny type, and it's going to say size of t is less than 4 is not satisfied. Because guess what? The size of long int is greater than 4. You can try and prove that by taking out this guy here and saying stdcout size of long int. We're going to see this print out. And if we build now, we're not going to violate our concept because we're not calling the function. The build is going to be good. What we want to do is run the program and see the size of long int. We can do this. Rooster 8, the size of long int is 8, and it is going to violate our tiny type concept. Okay, you can do things like this and combine concepts, but we can even put our concepts in place. We can do something crazy and, for example, say, let's copy this. And we're going to go down and say requires integral, but we're going to put tiny type in place. For example, we're going to grab the requires clause here and copy it and put that in place of tiny type here. We're going to do this, and you're going to see that this is going to be valid C++ syntax if we take out the semicolon, because it shouldn't be there. But look at this. This is really ugly. This is going to make your functions really hard to read, but it is going to work exactly the same way it did. If we call this function, we're going to violate tiny type. Let's do that. We're going to build with GCC. We have an error. Let's bring this up so that we can see what is wrong. Nested requirement size of t is not satisfied. This is a syntax you can use, but I don't really recommend this because this is going to make your code hard to read. And this is really all we set out to do in this lecture, looking at how we can combine our concepts using the AND operator and the OR operator. And you can really use this in all the syntaxes for concepts we have seen, but I just used this in this lecture because it is simpler to show. We are going to stop here in this lecture. The next one, we're going to look at concepts and auto. Go ahead and finish up here and meet me there.